In this video, the learner will classify angles and find their measures using a protractor. First, we're going to talk about what a ray is. A ray is a piece of a line with one endpoint extending infinitely in one direction. So we have this ray here. P is its endpoint, and then it extends infinitely in the direction of point R. We name a ray using the endpoint first and then another point on the ray. So we would name this ray PR. We would not be able to name this ray RP because we have to start with the endpoint in the name first. This name here says we're starting at P going in the direction of R. This ray would be starting at R and going in the direction of P, like this ray does here. Notice those are two different rays. I want you to name this ray starting at D going in the direction of A. Opposite rays are two rays that share the same endpoint and continue infinitely in opposite directions. So I have ray DA and ray DK here. If I were to bring them together, notice they would share that endpoint D and extend infinitely in both directions. Using the diagram here, I want you to answer and complete this sentence. Opposite rays make a blank. Now that we know what a ray is, we can start to construct angles. Two rays that meet at a point and extend infinitely form an angle. So we have the two rays here that share that endpoint, and they form that angle as the space between. The two rays are the sides of the angle, and the point at which they meet is the vertex of the angle. An angle separates the plane into three regions: the interior region, which is inside the angle, the exterior region, outside the angle, and the actual angle itself, all the points on each one of those rays. We measure angles in degrees using a protractor, and later in our course we'll talk about measuring angles in radians. Angles with equal measures are called congruent angles. Remember, we can say that the objects are congruent, but the measures would be equal. Angles can be named by the vertex point if there are no other angles at that vertex that could be confused. Three letters with the vertex as the center letter and the other letters representing points from each side. Or a small number if one is given in the angle. So these are the three possible ways to name angles. Now we're going to answer some questions about figure 1 and figure 2. We're going to first give the possible names for the angle in figure 1. The possible names for this angle, using the ways we just described, first would be angle B, and this would be the notation that we would use to name that angle. We can also use three letters with the vertex being the center letter, so we could have angle A, B, C. Notice A and C are points on either side of that angle. We could also name it CBA, as long as B is the center letter. Next, we're going to measure the angle in figure 1, and to do that, we're going to use our protractor. The protractor is a tool we use to measure angles. The numbers on here represent the amount of degrees in that angle. We know a straight line measures 180 degrees. You can see that we have two sets of numbers going from 0 to 180 degrees in both directions. To use a protractor, you're going to use the vertex of the protractor here and align that with the vertex of your angle. And you're also going to line up one of the sides of the angle with the 0 degree measure on the protractor. So let's use this protractor to measure this angle. So I'm going to line up the vertex on the vertex of my angle and line up one of the sides, that ray, with 0. Now I'm going to count from 0 the amount of degrees that that angle opens up to. So it's the amount of curve within that angle that we're measuring. So I'm going to measure that angle all the way to the other side, and we can see that angle measures 90 degrees. The way we would notate that is we would say the measure of angle B equals 90 degrees. This little M in front means measure. I want you guys to answer questions 2 and 3 on your own. Next, we're going to be classifying angles. You need to be able to classify angles by the amount of degrees within them. Acute angles measure more than 0 degrees but less than 90 degrees, similar to this angle here. I would like you to estimate what the degree measure of this angle could be. Right angles measure exactly 90 degrees, no more, no less. We indicate a right angle on the picture by this little box. If you don't see that box, you cannot assume that a right angle is present. Perpendicular lines form right angles. So we could say that these rays are perpendicular. This angle here is obtuse because it would measure greater than 90 degrees but less than 180. And this angle here is a straight angle and has a measure of exactly 180 degrees. Notice that a straight angle is made by opposite rays. They share this endpoint and go infinitely in opposite directions. I want you guys to classify the angles in Figure 1 and Figure 2 on your own.